Okay, this is section 2.2 geometry, statements, conditionals, and biconditionals. And we're going to begin talking about, we talked yesterday about inductive reasoning, and so we're going to go a little bit further on some things today. The first thing we're going to talk about is a statement, any kind of statement that we use in geometry. We're going to look at those today. We're going to talk about the truth of them. So I'm going to first of all talk about this. Let's put it this way. Let's change it a little bit differently. When you are going to be gone, you need to turn in your assignment before you go. Right? All right. Okay? That's not directed towards anybody. That's directed towards everybody. All right? So when you're going to be gone, you need to turn in your assignment before you go. This is a statement, okay? Now, what we have is what we call a truth value, okay? And the truth value of this is true. This is what Mr. Ellis asks you to do, okay? Some people choose not to do that, but that's what Mr. Ellis asks you to do. So every statement that we talk about has a truth value. Okay? For example, if I use one from geometry, all right, I would say something like this: a rectangle is a quadrilateral. True or false?
True.
And it's true. The truth value of that is true. Now, we can call this statement P, all right? And we use P or Q, all right? All right, now we're going to get to P's and Q's later on, but for right now we're going to use P's, Q's, and R's to generalize statements. Now what I want to do is I want to talk about the negation of P. All right, the negation of P. And we use a symbol for that. Now I'm going to write what the negation of P is in a minute, but we use a symbol like this. It looks like the similar statement. The negation of P says a rectangle is not a quadrilateral. Okay, so do you see the difference between the original and a negation? Okay, by putting the word not in, we negate what we said. All right? Okay. All right, so we're going to talk about then some things that, some statements that go together. All right? And we're going to talk about a compound statements. Okay? So, compound statements. Now, we already talked about statements and having a truth value, but now we're going to talk about compound statements. Compound statements are two or more statements joined by a word and or. Okay? So, two or more. Most of the time we use two or more statements joined by the words or and. Now that's kind of weird that I have or between them, but okay? Alright. So we're going to begin with the word and. Okay, we have two words here. We're going to begin with the word and this is a conjunction. This is called a conjunction. And we have a symbol for conjunction. It's this. It's a upside down V. All right? Okay, so let me start with P. Remember, P was a rectangle is a quadrilateral. Remember that? Do we remember that? Okay, so now we're gonna create a cube, and we're gonna say a rectangle is convex. Okay? So if we want to do a conjunction, we can say conjunction would be P, and then that's the symbol Q. So we're going to connect these two with an and. So we start with a rectangle is a quadrilateral and it is convex. Now, are both of those conjunctions true? Or that one conjunction, is it true? Is P true?
Yes.
Is Q true?
What's convex?
Convex means that it goes out, not in.
Yeah.
Yes. Okay. So, guess what? They're both true. So the truth value of the conjunction is true. All right? Okay, let's look at another example, shall we? I'm going to erase, and you're going to have to redo it. I'm going to erase this part of it. I'm going to keep the P and the Q. I'm going to add R. I'm just following the book here. The book actually has some great examples here. The figure is a triangle. You see that on page, and I'll draw it. It looks like this. This figure is a triangle. Okay. And then Q would be the figure has two congruent sides. Okay. And then we're going to add this one. The figure has three acute angles. All right. So, I want you to do P and R. All right? P and R. So I want you to do a conjunction with P. So, well, how would I say that?
Add
Okay, so I would say what?
the figure is a triangle and has two congruent sides.
I'm doing P and R.
Oh. That's not bad.
The figure is a triangle.
And the figure has three acute angles.
The figure is a triangle, and the figure has three acute angles. Is that true or false?
False.
That is false. Tell me why.
Because it only has two.
It only has two acute angles. The third angle is right, correct? All right. Now let's do Q, and let's do a conjunction with the negation of R. Okay? With the negation of R. All right, let's start with Q. What does it say, Connor?
The figure has two congruent sides.
And the negation of R.
The figure doesn't have three
The figure does not have three acute
angles.
angles. Let me say it again. The figure has two congruent sides, and the figure does not have three acute angles. Is that true or false?
True.
That is true. Look what happens when we negated that. Okay? Look what happens when we negated that. Any questions about that? All right. And what was that called?
Conjunction.
A conjunction. All right. So if there's a conjunction, guess what else is there? there's an or, and I'm going to erase this part up here. Okay, and I'm going to put or, right? And an or is a disjunction. And it looks like this. It looks like a V, right? Okay. Now, let's do P disjunction Q. Now, or is different. Or is, you know where and, they both had to be right in order for it to be true? Or only one has to be right. If I say, you know, Kellen or Aubrey went downtown, if either one of them went downtown, that's a true statement, right? Same with this. So if I look at P disjunction Q, I would say the figure is a triangle, or what?
Figure has two sides.
Or the figure has two congruent sides. Is that true or false? True. All right. Now let's look at, so this is true. So now let's look at P disjunction R. Now, Chet, would you read P disjunction R?
The figure is a triangle or the figure has three acute angles. It's false. And true.
It is actually true, Nelcha,
Oh.
because of the first one is true. All you have to do is have one of them, right? All right, let's do negative P. No, let's do negative Q. And the negation of Q so this is false. This was true, right? The negation of Q and the negation of R. Okay? Kagan, what would be the negation of Q? Okay, the figure does not have two congruent sides. Or is either one of those true?
Yes.
Yes. The second one is true, right? So that one is true, isn't it? So the only way to get a disjunction false is what?
Like neither of them are true.
What's that?
Neither of them are true.
Neither of them are true. Okay. Take a look at the bottom of page 120. They have a little chart there that can help you out. It says negation, a statement that has opposite meaning and truth value of the original statement, not P, is not read. Conjunction is a compound statement formed by joining two or more statements using the word and. Okay, and a disjunction is a compound statement formed joining two or more statements using the word or. That's a little summary of what we just talked about, correct? All right. All right, your whole life you have dealt with, by the way, what time is the bell ring? So I know. 50? Is the next period before lunch? Where do we go? Okay, all right. Been a few weeks, so. Okay, so the next thing we're going to talk about is actually where most of geometry and these things go. It's called a conditional statement. So referring back to the beginning, this is called an if-then statement. You dealt with them your whole life. If you don't think so, think about the way your parents talk to you. Right? If you don't take the trash out, then you're going to be in trouble. Right? Don't you have a lot of those? If you're not home by 9 o'clock, then you're going to get grounded. Right? All right? Even teachers do it. Right? If you're going to be gone, then you need to turn your assignment in before you go. Right? These are conditional statements. All right? They're if-then. So let's just take one. Let's do, not all conditional statements start out as an if-then. For example, let me give you an example here. A mammal is a warm-blooded animal. Okay, that is not an if-then statement. Why? It doesn't have if or then. Okay? So we want to put an if or then in there. So what do we say? If an animal I think it's if an animal is a mammal first, isn't it?
Does it
Because the
have to go
mammal's
on?
first, right? We want to try to keep it the same. I'm having trouble spelling mammal. If an animal is a mammal, then then it is warm blood.
It has two ends.
Okay. All right, so if an animal, now we put it in if then. If an animal is a mammal, then it is warm blooded, okay? This has what we call an hypothesis, and this is the if. And it also has a conclusion, which is the then. So what I'm saying is, now this is not included, so the hypothesis, I'm going to underline it once. An animal is a mammal. Notice that the if is not underlined. Notice that the if is not underlined. Notice that the if is not underlined. Then it is warm-blooded. We're going to underline the conclusion twice. Notice that the then is not underlined. Notice that the then is not underlined. Notice that the then is not underlined. Do you have it? If you're going to be gone, then you must turn in your assignment. I've said that 3 times also. All right? We got it? All right, so I'm going to give you another one, shall we? And then you're going to give me the hypothesis and the conclusion. You ready? All right. So let's talk about this. This one's a little harder. 4 quarters can be exchanged for a $1 bill. Okay, I want you to think about that for a minute, and let's try to put that in an if-then form, and then talk about the hypothesis and the conclusion. What time did you say the bell rang? 52? All right. So who wants to put this in if-then form? If take a guess.
If you have 4 quarters, then you can exchange it for a $1 bill.
All right. If you have 4 quarters, nice, Nelcha.
Maybe this is a smart seat.
If you have 4 quarters, it's the seat, huh?
Yeah.
Then, if you have 4 quarters, then you can exchange it for $1 bill, right? All right. So what is the hypothesis, Kagan? You have 4 quarters, not the if. And then Connor, what is the conclusion?
You can exchange it for $1.
Okay, what's the truth value of this? Now, oh, we jump back to the truth value. What's the truth value of this?
True.
It's true. It's true, correct? All right. Turn to page 122, please. All right. At the top of the page, I have highlighted both these paragraphs. To show that a conditional is true, you must show that for each case, when the hypothesis is true, the conclusion is also true. To show that a conditional is false, you need only to find one counterexample. If I say, if you are in Mr. Ellis's geometry class, then you are a boy, Kellen is a counterexample, right? If I say, if you are in Mr. Ellis's geometry class, then you are 15 years old. Is there any counterexamples? All right, there's some counterexamples. All right, so, but I can say things like, if a figure is a rectangle, then it is a quadrilateral. What's the truth value of that?
True.
If a figure is a rectangle, then it is a quadrilateral.
True.
It's true. All right. All right, so let's take a look at example 4 on page 122. It says determine the truth value of each conditional statement. If true, explain your reasoning. If false, give a counter example. If you divide an integer by another integer, the result is also an integer. True or false? She says true. 5 divided by 3 is 1 2/3. Is 1 2/3 an integer? No, it's not true. That's a counterexample. Let's take a look at the next one. If next month is August, then this month is July.
True.
True. July or August follows July. All right. Now, I'm about ready to blow your world apart. Okay? C. If a triangle has 4 sides, then it is concave.
False.
True.
False.
It does not have four
You
sides.
listened to me, didn't you?
Yeah.
It starts out by saying if a triangle has 4 sides. A triangle does, so the hypothesis is false. I'm going to read something to you. Remember I said both paragraphs I highlighted at the top of the page. Let's go to the second paragraph at the top of the page. When the hypothesis of a conditional is not met, the truth of the conditional cannot be determined. When the truth of a conditional statement cannot be determined, it is considered true by default. This blows students away. If the hypothesis is false, a triangle having 4 sides, the whole thing has a truth value of true. I know it doesn't make sense. It's almost like it's a counter example, isn't it? But if I say, I can't use gender anymore, if Dylan is 7 feet tall, whatever comes afterwards is true, because Dylan is not 7 feet tall. Do you understand what I'm saying? So if the hypothesis is false, the whole thing is true. Regardless, don't even have to read on. They could say blah, blah, blah. It's true. You understand what I'm saying?
Yeah.
This is weird. I get it. Okay. All right, so this is a conditional. So I'm going to come up with just a conditional statement that we can all agree on. All right, so we're not offensive. Let's go back to our rectangle one, because that seems to be a fun one to do. If a figure is a rectangle, then it, then it is a quadrilateral, right? Do we agree with this? All right. This is the original. Here's the hypothesis, and here is the conclusion. We're good, all right? So the first thing I'm going to talk to you about is a converse. Okay, so let's go back real quick. If I can write this using P's and Q's, remember our P's and Q's? I would say this original, I would say if P, then Q. That's one way to write it. The book writes it like this. If P, then Q. Either way is fine. All right? You get it? Okay. So now I'm going to talk about a converse. A converse is, you ready? As I flip Q and P. By the way, this true statement was true, right?
Yes.
All right, so I'm going to flip P and Q. So I'm going to go Q, then P. So the converse of this is if a figure is a quadrilateral, then it is a rectangle. All right? I flip the hypothesis and the conclusion, don't I? I flip the hypothesis and conclusion. And so this is actually false, isn't it? Now, what I'm going to do then, the next thing is I'm going to do the inverse. The inverse is not P, not Q. So I turn it back around so it was normal, but now I do the negation of the hypothesis and the negation of the conclusion. So I say if a figure is not a rectangle, then it is not a quadrilateral. Now, what's the truth value on that? Could it be a four-sided figure?
False.
Could it be this? Isn't that a four-sided figure?
Yeah.
Is that a quadrilateral? Yes. So that one's false, isn't it? So it matches the converse, doesn't it? The converse was false, right? Now we're going to have what we call a contrapositive. And this is, you turn it around and you negate it. So not Q, not P. So not only do you flip the hypothesis and the conclusion, but you negate both of them. So now you start out by saying if a figure, can you see this up on the board? Okay. If a figure is not a quadrilateral, then it is not a rectangle. True or false? True or false?
True.
True. Isn't that weird? Kagan. The original was true and the contrapositive was true. They will always have the same truth value. So they'll either both be false or they'll both be true. Do you understand what I'm saying? The converse, which was false, and the inverse, which are false, they will always have the same truth values. They'll either both be true or they'll both be false. Do you understand what I'm saying? Okay? So regardless, if I give you an original conditional and it's true, then the contrapositive is true. If I give you an original and it's false, the contrapositive is false. If I give you an original and it's false, the inverse and the... I'm not saying the inverse and the converse have to be the opposite. I'm just saying they will be the same as each other. Okay? Does that make sense? Okay, now, on page 124, if you'll turn there real quick, we'll finish it up. It says a biconditionals, inverses, converses, converse, positive are statements related to conditionals. If you make a compound statement from a conditional statement and its converse, then you can write them as a single biconditional statement. Okay? So if I take the original and its converse, and I put them together as a conjunction, okay, you can make a biconditional statement. Now, if they're both true, we have a true biconditional statement. Let me see if I can come up with an example. Okay, let me see if I can come up with an example. Okay, let's say that I have, if two angles, let's put it this way. If the sum of two angles is 90 degrees, then the two angles are complementary. That true?
Yes.
All right, let's take a look at this. Let's take a look at the converse. What's the converse? The converse is, if two angles are complementary,
Then the sum of the angles.
then the sum of the two angles is 90 degrees. Is that also true?
Yes.
Yes. So here's a case where the original and its converse are true. So we can write it, and here's how we write it, okay? The biconditional. It's kind of weird. It's kind of weird. It goes like this. The sum of, this is two angles, is 90 degrees if and only if the two angles are complementary. The if and the then, or if whatever, is in the middle.
What's after 90? Is
The sum of two angles is 90, oh, I said it twice. The sum of two angles is 90 degrees, sorry, if and only if the two angles are complementary. This is what we call a biconditional. Alright, my writing stinks.
So then they're all gonna be true, right?
No.
Because if the converse is true too, right?
Right, if both of them are true. Now, most of the time in geometry, the author will say, or if there's a question, it'll say, if the original and its converse is true, then write a biconditional. Because biconditionals, most of the time, we want them true. So the only time they'll really ask you is whether it's true or false. Now, in this book is different than my last book. It would never write it. Sometimes they ask you to write a biconditional, and then they ask you if it's true or false. Okay? This book does that a lot more than my old book. My old book would say, is the original true? If the original and its converse is true, write a biconditional. You see what I'm saying? So that was in the old days. Okay? Alright, so here's your assignment. Your assignment is page 126, and could I have one of you write that up on the board?
It's
Page,
already on here.
oh, page 126, 28 through 50 even, and then 58
70.
through 78, is that even?
Yep.
And you have tomorrow to work on it, I believe? Yeah, you have tomorrow to work on it. All right? Okay.